Hello, my name is Mira and my partner is Eugene. This summer we worked on artificial intelligence for modern board games with Sean. The board game that we chose is Pandemic, which is a cooperative European-styled board game. And the goal of the game is to cure all 4 of the diseases, which are red, blue, yellow, and black on the board. The players are given the task of curing these, and in order to win, you have to cure all 4 of the diseases. So the players are working together to travel to all the different cities to cure the 4 diseases. Now, during the game, there are outbreaks that happen. Outbreaks happen after 4 cubes are placed in one city, and after an outbreak happens, a cube is spread to every adjacent city during the game. There are different ways of losing, including outbreaks reaching 8, running out of player cards, or running out of cubes. Cubes are used on the board to infect the different cities. In the deck, there are epidemic cards. There are 4 to 6 epidemic cards during the game. An epidemic card, once pulled, adds 3 cubes to the city that is pulled from it, and it is then reshuffled within the deck, along with all the cards in the infection deck discard pile. After the infection rate is increased, and you continue to play the game. The players have 4 actions every round to play, and these actions can be used to share cards with other players, drive to different places on the board, or fly other places. There are certain actions that help a player win, including trading cards and curing diseases, and there are certain actions that delay outbreaks from happening, and these are treating cubes and moving towards congested cities, which are just cities that have a lot of cubes that are in the area within each other. A player has to have 5 cards of one color in order to cure disease, and after they cure disease, you have to go to a research station to be able to do it. And during the game, they can set up different research stations. Research stations help you move easier along the game, and they also are used to cure the different diseases.
All right, so we had to do a lot of stuff to get this to work on a computer. So the first problem is that there are way too many possible moves for the AI to consider at each turn. So for example, this game has around 10,000 possible moves per turn. So even though it's technically possible for a computer to handle all of this, it would take a long time. So it's not really feasible for this game to do it normally. So what we do is we abstract the moves into plans. So instead of having small, simple moves such as drive from Madrid to Algiers, or something like give the Algiers card to player 2, we've combined several of these smaller moves into larger, more abstract moves, such as get to Algiers and treat the disease there, or trade with all the players to get 5 red cards. This way, there's much fewer possible moves per turn for an AI to keep track of at the same time. So now that we have a bunch of plans, we need to be able to pick which plan is the most effective, which plan is the best one that we can do. So we look at 2 main metrics per each plan. So we look at time to lose and time to win. These are pretty self-explanatory. So time to lose is how many turns or how many actions it would take for us to lose the game if nobody did anything. So what we do is, to calculate this, what we do is we create a copy of the current game state, and we just simulate new turns over and over and over again until eventually we lose the game because we haven't done anything, and we just count how many turns it takes. And we do this simulation thing about a few hundred times, and we average it all out to get an accurate number of how many actions it would take for us to lose if nobody did anything. And for time to win is similar. Time to win is how many actions it would take for us to win as fast as possible. And this is an approximation. We use a bunch of probabilities of stuff like how long it will take for us to get 5 cards of the red card. How long will it take for us to get 5 red cards of the same color by drawing from the deck? How many turns it would take? How many turns it would take on average to meet up with all the players to trade red cards? Or how many actions it would take on average for us to reach a research station to actually cure the disease. And we can use this to get an approximation of time to win. So with time to lose and time to win, we can figure out how effective a certain plan is. So what we do is we figure out what we're trying to do is we're trying to win before we lose. So what we do is we try to maximize time to lose, and we're trying to minimize time to win. So this is how we actually evaluate each of our plans. So in summary, our AI works by generating all of the possible abstract plans. We rate each one in terms of time to win and time to lose. Then we use these metrics to choose the most effective plan from the list. We execute the plan, and then we just do it over again until we eventually lose or win. So the current state of our AI is that right now it has some limited functionality because we weren't able to implement everything. But what it can do right now is it can calculate time to win and calculate time to lose. And right now what it can do is it will go around, figure out which city is the most under threat, or which city has the most threatening cube count and stuff like that. It will go to that city, take into account stuff like how long it will take for us to get to a certain city and which one is the most effective use of our time, go there, get rid of some cubes, and push back the disease. And also what it can do is once you have five cars of the same color, it will actually try to go to a research station and cure it if it's the best move to do. And that's the current state of our game. Thanks.